Welcome to Plutus IAS, and today we are covering phosphazene. So, phosphazene compounds are. First, let's discuss where does this come? Well, this is a subtopic that we study under the main unit, main group chemistry. Main group chemistry, which belongs to your paper 1 of the mains. Paper 1. So here the word phosphazene and why it is important, we need to define that. So first, the word phosphor in the phosphazene means that it contains phosphorus as its one of the main atoms. While azene compounds means ene means it will be double bonded and aze means bonded with nitrogen. So phosphazenes are phosphorus-nitrogen containing compounds which exist in the form of PN R2 with N, where the N can be refers to N can be 3, 4, 5 and 6, where the value N 3 and 4 corresponds to what? It corresponds to planar phosphazenes. Planar phosphazenes, while 5, 6 refers to the cyclic phosphazenes that have near planar structure. Near planar structure, that means they are somewhat in three-dimensional plane. Near planar. So the most important compound that we have that we are discussing is the cyclic phosphazene, which is a trimer, of the form NPR2 3. When three such units combine together, they give you cyclic phosphazene. Cyclic phosphazene or trimer of phosphazene. Phosphazene. One more important thing that we need to remember here, the R. The R can be fluorine, chlorine, bromine, OH, hydrogens, and can be OR compounds, etc. But remember, you will never encounter R as iodine here because the compound formed by substitution of iodine are not that much stable, and there are very limited number of examples that exist for it because the bond length between phosphorus and iodine is much larger. So the reactions are reversible, and that's why we are not discussing any substitution that is regarding the iodine. So next thing, the specific example that we are talking about, I'm taking the ligand here as Cl. So it exists like this, which is phosphorus right here, then nitrogen, phosphorus, nitrogen, here it is phosphorus. Now it contains alternating double bonds with phosphorus being pentavalent atoms, phosphorus being pentavalent in nature, while nitrogen remains in trivalent. Every single nitrogen here contains a lone pair which is present in its sp2 hybridized orbital. Here, all the nitrogen that exist here, they are sp2 hybridized, while all the phosphorus that exist here, they are in sp3 hybridized. Now, if you look closely, you will see that this compound is analogous to, this is analogous to benzene. Why? Because it is isoelectronic and isostructural with benzene. Isostructural with benzene. So now let's move a little bit further in the discussion. Wait, let me copy the slide. Now removing everything which we think is extra. So if you see here the nitrogen that exists, the nitrogen is sp2 hybridized where the lone pairs are present in the sp2 hybrid orbitals. So here we have two bonds, two sigma bonds that are formed by sp2 hybridized orbital, and this orbital right here, lone pair, will also be there in sp2. While for the formation of the pi bond with the phosphorus, this nitrogen will also have a vacant p orbital. For this case, I'm assuming this is my pz orbital, which has one vacant orbital right here, and this how the nitrogen is pentavalent in nature. Now, similarly, if you talk for phosphorus, phosphorus is pentavalent in nature. The phosphorus will be pentavalent in nature, sp3, with 4 sigma bonds being formed, and the pi bond will be formed by the one electron present in the dxz orbital. Why we are specifically looking for the dxz orbital? It's because here the z orbital you have chosen is a pz orbital, and since we are taking pz, the orbital which is capable of pi bonding should also have elements of z symmetry. That's why pz will overlap with dx orbital specifically. Now, with this, we can more define about phosphine. That first of all, you can see that the phosphine right here, the phosphazene, contains phosphorus as well as nitrogen. In this, you will encounter that the bond between phosphorus and chlorine are of the length of 197 picometer, which are very large. Hence, this Cl bonds can easily be broken or be substituted with another ligand, and that is responsible for substitution reactions that makes phosphazene very susceptible towards substitution reaction. Number one. Second thing, the nitrogen right here contains lone pair, and since it contains lone pair, that means any other electrophilic species can attack it, which make it susceptible to addition reactions. Addition reaction. Now, third reaction, if you heat this, if you are heating the phosphazene at a temperature greater than 250 degrees Celsius, it has also the tendency to undergo polymerization. Polymerization. Now, one more thing. In the very start, we discussed that phosphazene contains aromatic nature. Now, since it contains aromatic nature, what does it mean? Aromatic nature means it has to be perfectly aromatic. It should obey all the properties of benzene. But the difference is that phosphazene phosphazene is very less aromatic compared to benzene. That means it is also very reactive. This is for reactive than benzene. That's why substitution, addition, and polymerization is not known for benzene, but not by simply heating, but for phosphazene it is possible. This arises because the electronegative difference between the phosphorus and nitrogen that exists. Nitrogen being more electronegative, the pi electron density exists more on nitrogen than in the phosphorus. So that means the electron cloud, which is symmetrical in a benzene, is benzene. In phosphorus, in phosphazene type of compound, phosphorus, nitrogen, it is somewhat lumpy. That means it has directional characters. That means it is not properly aligned. Because of this, the phosphazene has much higher reactivity compared to benzene. So these are the key differences and the reactions that the phosphazene undergo. And with this, you can understand what is the actual properties that and the reactivity that we can define using phosphazenes. These the bond lengths, the aromatic structure based on the electronegative difference between phosphorus and nitrogen, as well as the the lone pair that are present on nitrogen. So that's it for today from my side. I hope you learned something about phosphazene. In next class, we'll try to compare borazine and learn about why it is better than phosphazene and its aromatic nature, the reaction it takes place, and many more about it. If you have any doubts, you can add it to the comment section and we'll try to get back to you. Thank you for joining us.